Question 2. This is an energy related question. You're given the context of a battery operated remote control car and you're told in 2.1 the car's battery contains a store of energy. This is going to be vital as you're going to have to remember what type of energy is stored inside a battery. Chemical energy. You're told as the car moves, energy from one store is transferred to another store. Describe, for 2 marks, how different stores of energy change as the car moves. Now, being that it's only worth 2 marks, you're not required to put a huge amount of detail in. You could talk about how the chemicals energy store is transferred to, say, kinetic energy, sound energy, and maybe heat energy. But really here, as it's all worth 2 marks, you only need to talk about how the initial chemical energy store changes and ultimately how that energy ends up at the end. So for the first mark, you simply need to say the store of chemical energy decreases. So this store of energy will be transferred into different other stores. Ultimately, all the energy will be transferred to heat energy. Now, because internal energy is now part of the new science specification, it's best to give your answer in terms of how the internal energy of the surroundings, where this heat energy goes, how that would be affected. So for the second mark, you could say that the internal energy of the surrounding air increases. (2.2) you have to recall the kinetic energy equation. It's not given to you on the equation sheet. So, what equation links kinetic energy, mass and speed? Best to write it in words. Kinetic energy is equal to 1/2 times the mass times by the speed squared. Very important you remember that the speed is a squared. 2.3 then requires you to actually use this with some numbers to come to an answer of the maximum kinetic energy of this battery operated remote control car. So kinetic energy is equal to 1/2 times the mass times by the speed squared. Now the information you need is given to you just above 2.2. You're told the top speed is 12 meters per second and it has a mass of 800 grams. Be very careful here. You need to be working in kilograms. So this needs converting to kilograms, which would be 0.8 kilograms. So put the numbers in. So 1/2 times 0.8 times by 12 squared. Put that into your calculator and you'll get an answer of 57.6 joules. If one of these options here is given to you, remember to put the answer in. The units have already been given to you, so there'll be no mark for that. 2.4 requires you to remember what efficiency means. So you're asked, explain why having a more efficient motor increases the top speed of the car. So when we're talking about speed in terms of energy, we should be thinking about kinetic energy. The more kinetic energy something has, the more speed it's likely to have. Efficiency is all about how much of the input energy is usefully used. We don't want to be wasting energy. So a very efficient system will not waste very much energy at all. So if we want more energy to go to our motor, we've got to waste less energy. So if we have a more efficient motor, for 1 mark, less energy is wasted, less wasted energy. A low proportion is wasted. And for the second mark, there's a higher proportion or more energy converted to kinetic energy. It is vital you state kinetic energy and not just a useful form of energy. It must be kinetic. The final part of question 2 is an analysis question. You're giving some data about an electric car and a petrol engine car. And first and foremost, you're told which car will be the most economic over its 12-year lifetime. You've got to use the data given to you in the table, and you should include the difference in cost in your answer. To get 1 or 2 marks on this, you would only make simple comparisons. So, for example, the electric car costs £12,000 more than the petrol engine car. That would be a simple comparison. And that would be about it. You perhaps then come up with a conclusion, and the conclusion may or may not be consistent with any other calculations you performed. To be aiming for 3 or 4 marks, you need quite a lot more detailed analysis of the information given to you. You must draw a conclusion which is consistent with your calculations and your reasoning, and you must refer to the payback time for the vehicles. Alright, so there's several ways of doing this, but here's one way perhaps of going about getting the full marks. You can start off simply with what we said before. The electric car costs £12,000 more. Then we can start looking at the running costs. Look at the electric car first. Over the 12-year period, the electric car is going to cost £250 per year. So, overall that's going to cost £3,000 over the 12 years. 250 times by 12. Do a similar comparison for the petrol car. Well, that costs £2,000 per year to run. Times that by 12 and it costs £24,000. We could then therefore look at the total cost of both of those vehicles over those 12 years. So the total cost of electric car is the £27,000 it cost to buy it plus the £3,000 running costs. So £30,000. If we look at the total cost of the petrol car, well, it costs £15,000 to buy and it costs £24,000 to run. So over the 12-year period, it's going to cost £39,000. So it's going to cost you £9,000 more. This means that per year, the electric car is £750 cheaper. And so your conclusion would be that the electric car is cheaper over the 12 years. There's one final thing you could do to ensure full marks, and then let's look at payback time. So we know the electric car costs £12,000 more than the petrol engine car. But every single year, the electric car costs £1,750 less than the petrol engine car. £2,000 per year for the petrol, £250 for the electric car. So every year that goes by, we're going to save £1,750. So if you divide 12,000 divided by the £1,750, it's going to take 6.9 years to get your money back through the savings. After that time, the electric car is essentially far cheaper, making more profit than the petrol car would, and hence that's where the £9,000 comes from. All of this should get you 4 marks.